Assalamu alaikum. My name is Sabah Tahir. I am from physics department and today's my topic for presentation is Cern, European Council for Nuclear Research. So let's start. Cern. CERN is actually the European Council for Nuclear Research, a provisional body founded in 1952 with the mandate of establishing a world-class fundamental physics research organization in Europe. It was established for the purpose of collaborative research into high-energy particle physics. The scientists used the largest and most complex scientific instruments to study the basic constituents of matter, the fundamental particles. Subatomic particles are made to collide together even close at the speed of light. Here are the projects of CERN. There are a lot of projects done by CERN, but here we discuss some of them. IDA Innova, black hole, the standard model of particle physics. So, creating black holes. What are actually black holes? Black holes are regions of space having a gravitational field so intense that no matter or radiation can escape. Is actually the black hole. July 4th, 2012, and scientists from CERN stepped in front of hordes of journalists to unveil a scientific discovery that signals a new dawn in understanding our universe. Researchers created what's been called humanity's largest and most complex scientific experiment, a 27-kilometer one-of-a-kind machine buried some 175 kilometers below ground to discover Higgs boson, a pivotal building block of our universe. So the Higgs boson is a fascinating particle because it's the simplest one, thus has completely changed our vision of universe. Because correlating the fact that there is a Higgs boson means we live in the vacuum. That is very special. Because it has no change, it has to change a lot on the way we think about ideas in general. The boson is a part of what physics all standard models, a way of explaining what for 13.8 billion years has held particle together, maintaining our universe. That is just one problem no scientist had ever detached. That's where the Large Hadron Collider comes in, so they are accelerating protons in opposite direction to very high energies in 27-kilometer long tunnel, and then they bring them collisions in different interaction points where they have done experiments. Here is actually the three-dimensional image of data which taking in this experiment. Teams like Oliver's from Geneva to Chicago analyze the debris of millions of collisions. They say recreates the beginnings of the universe. The next project is IDA Innova project. The IDA Innova project is the detectors are made up of the layers and layers of sub-detectors, and the challenge is making each of them faster and more efficient. It becomes an ever bigger challenge. The IDA Innova project can see it brings together different people from different industries and backgrounds from all across Europe to create perfect fit particle physics. Research is involved in dome of most completed experiments in science. It cannot be done in a single country or group of researchers. It requires the collective effort of physics engineers and all kind of technical specialists. IDENOVA is an unparalleled opportunity to bring together workers from across Europe, not only get the best physics out of detectors, but to engage with the support Europe industry and science. The third project is standard models of particle physics. What is actually particle physics? The branch of physics which deals with the study of interactions, relationships, and properties of subatomic particles is called particle physics. The object of particle physics is to understand the basic laws in nature, all the way from the largest dimensions in the universe formation of galaxy and stars all the way down to the smallest dimension in the micron. As we know about different elements in nature, we know about helium, hydrogen, oxygen, lead, and so on. They all made up of different elements, which a great simplification was made they realized that all atoms are made up of particles. They are protons, neutrons, electrons, and just by adding more protons and more electrons, we get different elements. But it became complicated in 20th century when they have found many particles from cosmic rays. It was not really a system established to organize. They called these particles sigma, pi, delta. So they started organizing these particles on the basis of properties like spin, electrical charge. They noticed actually that there are many other particles like mesons, bosons, gluons, bosons, leptons, baryons, and many other antiparticles. The scientists at CERN actually collide these particles, like they collide electrons and founded other particles from their collision. The scientists then researched on the debris after collision and then they analyze the data from it. So this is what we scientists do at CERN. Here is actually the electron-positron collision at CERN. The largest electron-positron collider was one of the largest particle accelerators ever constructed. It was built at CERN, a multinational center for research in nuclear and particle physics near Geneva, Switzerland. LEP collided electrons with positrons at energies that reached 209 giga electron volt. CERN currently working on current working is on the world's largest and most powerful particle accelerator is getting new experiment in March 2021. The CERN reaches board approached the ninth experiment at Hardens ninth experiment at Large Hadrons Collider or Scattering and Neutrino Detector at LHC. So this is all about the CERN and their projects and the current projects. So this was my presentation. Thank you so much.